Our title today is Solution Concentration. And so what we're going to talk about today, guys, is what are all the different ways that we measure how much solute we have in a solution compared to solvent. Okay, so just to remind us, we're going to write this down again, even though I know that you have it somewhere else in your notes. A solution is a homogeneous mixture. Okay, and that means that it is the same throughout. That there's no one place that's more concentrated with solute compared to another place in that solution. But that the solute is uniformly distributed in the solvent. And so this right here, this is not a solution, right? Because these things are not uniformly distributed throughout. This is definitely not a solution. Okay, now solutions can either be gas, liquids, or solids. So it can either be a gas, a liquid, or a solid. We don't really think of solids or gases as being solutions, but actually they are. So air is a gaseous solution, pretty much uniform throughout. Now, of course, there's going to be some places where, like right outside the exhaust pipe of the car, that's not going to be uniform compared to 10 feet behind the car. But in general, like if we're talking about this classroom, the air in here is definitely a solution. Solids, really, we would think of like a metal alloy. So for instance, steel. Steel is a mixture, it's homogeneous throughout. So it's got different elements in there, but they are evenly distributed throughout it. All right, again with this vocabulary. The solvent is the dissolving media. And really, you guys, it's whatever is in the biggest amount. By definition is what the solvent is. So if we use, for an example, salt water, water is going to be the solvent. Okay, so for example, in salt water, example, water is a solvent. So then if we have a solution of salt water, water is our solvent, what is the salt? What is the word that we use to describe the salt? The salt is the solute. So the solute is what is being dissolved. Okay, so we just want to make sure that we're all using the same vocabulary. So for instance, for example, salt. Okay, if we're talking about the salt water. There are numerous ways, lots of different ways we can describe how much solute there is compared to solvent. So there are numerous ways. To describe concentration. that is to describe concentration of a solution. And we've talked about concentration already, but that is how much solute is there versus solvent. Okay, so we've already talked about one way in depth. So what is one way that we can describe the concentration of solute compared to solvent? Well, molarity, right? It's big M. And that is molarity. And the units for molarity are moles per liter. So, moles of solute per liter of solution. Okay. But there's other ways. How else? Mass percent is another way to describe solution concentration. And that is the mass of the solute divided by the mass of the solution, the total solution, so that would be solute plus solvent, and then because it's a percent times 100. Okay, there's also the mole fraction. And what is the mole fraction? It is moles of solute divided by moles of solute plus solvent. Okay. My years of working in science, you guys, I have not seen this. We didn't ever use this. Not really even this one either. Yes, this one all the time gets used in biochemistry labs. Now, we're not done though with our list. We also have molality, which we will use this week, talking about colligative properties. So molality is little m, molality, and that is moles of solute over kilograms of solvent. This one we will use. And a good possibility that you would see this one as well on the AP exam. What you will see, I'll show you your equation sheet, and on the equation sheet there is actually the formula for this. Okay, so there's molality. Now, there's another one that we used a lot in the labs that I worked in. And that was a percent solution, a little bit different than mass. Okay, and again, you guys, it really depends on the context, the lab that you're working in, what it is you're trying to measure in terms of which of these forms of communication you're going to use in terms of concentration of solution. Okay, so we use this a lot. So for instance, let's say we've got a 32% solution. Okay, what does that mean? That means that there are 32 grams of solute for every 100 milliliters of solvent. So this one was another one that we used a lot. 32% solution. 32. So whatever. So this is an example, not the number. So for instance, what would a 16% solution? What would that be? That would be 16 grams of solute per 100 mils of solvent. So keep in mind, people, this isn't measuring up to 100 mils. It's taking 16 grams and adding 100 mils of solvent to it. Okay, so that's what these kind of percent solutions are. And then, last but not least, and this one is important when we're talking about water quality. So we're talking about pollutants or how much there is of, well, pollutants, minerals in solution. So very, very, very small amounts can be measured in ppm, which is parts per million. So many pollutants, the accepted amount that you could have in a water sample are reported in parts per million. And that means you can have it, that would be 1 milligram per liter. So let's say if this would be 1 part per million. If you could have 5 parts per million, that would be 5 milligrams per liter. And then there's even a smaller one, which is parts per billion. Parts per billion. And these are for heavily carcinogenic things, organics in water, right? We're not allowed to have hardly any organic compounds in our drinking water at all because they can be very, very carcinogenic in that they can have been shown in laboratory animals to cause cancer. So this is parts per billion. And that, for instance, if it was 1 part per billion, it would be 1 microgram per liter, which is 1,000th of a milligram. 1 times 10 to the minus 6 is what a microgram is. All right, so here we have all these different ways that we can report concentration of solute versus solvent, and tomorrow we'll do problems, okay?